Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video is about how to model a forebay in Ideal. A properly designed forebay acts as a small pond that treats runoff before it enters the main pond. The small pond and the main pond act separately until the depth in the larger portion is equal to the height of the forebay dam. In some cases, a forebay is separated from the main pond with a stone or other porous material, and the purpose is simply to encourage the deposition of large particles in one area of the pond to make sediment removal easier. In other cases, an earthen dam is used to split a pond into two or more areas, effectively making multiple separate ponds until the water level rises over the top of the dam. When a porous dam is used to create a forebay, it does not provide significant additional treatment compared to that same pond without a forebay. Therefore, porous dams should be ignored in Ideal and the pond modeled the same as it would be without a forebay. When a pond is designed with an earthen or otherwise impermeable forebay dam, it can be included in the Ideal model. Since the condition exists where there are two separate ponds, the modeler must use two ponds to model this situation. Modeling the forebay as a separate pond will mean that its depth will be controlled by the spillway. In the case of a forebay, the spillway will be very long compared to the surface area and the inflow rate, so the depth will likely never exceed several inches above the dam, even in extreme weather events. Because the depth in the first pond, the forebay, cannot be controlled by the depth of the second pond, the main pool, in Ideal, the simulated depths of the two ponds will not be equal in conditions where it is clear that the entire pond, the forebay plus the main pool, would, in reality, be filled to a single uniform depth. Therefore, in order to accomplish the simulation of the single pond condition, some modeling adjustments are necessary. The forebay should be modeled first. The modeling of the main pond will depend on the results of the forebay modeling. This process assumes that the pond and forebay have been designed to meet all applicable standards for flood control and channel protection. Model the designed forebay using a dry detention pond object, as shown in this example model. The stage area inputs table for the forebay should be filled in up to the top of the designed pond. Keep in mind that the forebay dam should be extended straight upwards like an imaginary wall, not having the side slopes that the rest of the sides will have. Notice the diagram on the screen for assistance. The forebay will not have a riser in actuality, but Ideal requires riser inputs for all ponds. Therefore, you should make a riser that will not allow any flow through. The easiest way to do this is to model a very tall riser with no orifices. We recommend making the riser height 99 feet so that it is an obvious fictitious value. The riser diameter must be larger than the barrel, but as long as there are no orifices, it doesn't matter how large these dimensions are. Ensure that you do not specify an orifice. For the forebay, the emergency spillway will be the primary means of discharge. The emergency spillway input should be filled in according to the dimensions of the designed forebay dam. Another dry detention pond object is used to model the main pond area, and the two ponds are connected using a non-routed connector. Before discussing the inputs for the main pond, consider this. Ideal treats all pond outfalls as free overfalls, so the depth of the main pond cannot affect the depth in the forebay. See this scenario depicted on the diagram. This creates an issue because this means that the main pool actually loses the volume that would have been to the left of the imaginary wall in the forebay. In this scenario, the main pool could be full, but the forebay would still be at a depth just above the dam height. To compensate for that loss of available storage volume, the lost storage space in the forebay must be added to the main pool at the correct stage. The goal is to get the main pool to look like the designed pond with a section cut out for the forebay, as shown in the theoretical main pool modeling aid diagram. The correct modeling process is more clearly depicted in this diagram. The lost forebay area is restored in the main pond area. The correctly modeled main pond will only differ from the actual design pond in the stage area inputs table. For every stage below the top of the forebay, simply subtract the forebay's area from the design pond's area to find the main pond area. Make sure there is a stage area input for the depth in the forebay, which may have to be interpolated from the design stage area table. Make the next stage just 0.01 feet higher and begin entering the stage area for the pond as designed. This area may also need to be interpolated. Entering the areas for the maximum stage in the forebay and the next one just slightly above that ensures a flat slope, as shown in the correct modeling scenario diagram. This design process may also be applied to dry ponds with check dams surrounding the outlet structure. In all cases, the forebay or forebay-like area must be modeled first, and the main pond must contain the outlet structure and be modified to compensate for the loss of space above the forebay's depth. Thank you for using Ideal. As always, if you have any questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.